Welcome to consumer behavior, where we're going to look at utility functions and the indifference curves. We explore the concept of marginal rate of substitution, how to factor in the Lagrangian functions using the budget constraints, and also how to maximize utility. So there are two basic theories that we're going to really look at. There's what we call the ordinal, and there's what we call the cardinal theory. The ordinal theory simply assumes that utility is measurable, that as one price is equal to satisfaction, as you get to eat more, the total utility becomes incremental. This brings about the law of diminishing returns. So utility, to start with, is a measure of satisfaction. So utility is measured in utils. It measures satisfaction. Now this satisfaction in utils is illustrated by indifference curves. Indifference curves look like this. Now indifference curves have several characteristics. They illustrate the utility usurped from two goods X and Y. So you need to know the characteristics of utility in indifference curves. What are the characteristics of indifference curves? There are about 5 key. Who can give us?
They are convex to origin.
If you're together with somebody who's online, please make sure the other one is muted.
Sorry for that. Convex to origin, and they do not cross.
Don't crisscross, correct? They're convex to the origin. Okay? Convex to the origin. Number 2, they are non-intersecting. So they don't intersect each other. So non-intersecting, generally, they represent different levels of utility. So there is a question that I'll talk about that comes about from indifference curves. Not crisscrossing. Why shouldn't they crisscross? So like she said, they are convex, meaning they give the origin the back. That's what it means to be convex. They're usually reflecting the law of diminishing returns, to say, as you increase satisfaction of one good, maybe from 3 to 4, you'll be reducing satisfaction of another from maybe 5 to 2. So this simply implies, what are the characteristics? Okay, so the characteristic that as you increase 1 unit of good Y, you decrease. So this is what convex means. It reflects the law of diminishing marginal returns. So it is non-intersecting. You can never have indifference curves that come out like this, because the indifference curve on the right gives higher utility than the one on the left. So the indifference curve 3 is the highest, followed by 2, followed by 1. However, if we are limited by a budget line, indifference curve is only optimal at point B, because this is a point where utility is maximized. So they're non-intersecting. Generally, they do not, because each of these levels will represent different levels of satisfaction. So higher indifference curves have higher utility. Like I've said, indifference curve 3 is greater than indifference curve 2, which is greater than indifference curve 1. Okay, What other characteristics do we know about indifference curves? What other characteristics do we know about indifference curves? So that question alone would carry a good number of marks. So you need to know these characteristics. Okay, so they have a negative slope. They do not touch the axis. They are infinite. They do not intersect each other. They're convex. And also along the indifference curve, total utility is constant, but the marginal rate of substitution is what changes from one point to another. So what is the marginal rate of substitution? Marginal rate of substitution simply is defined as a quantity of one which the consumer is willing to sacrifice in order to buy an extra unit of another, whilst maintaining the same indifference curve. So the movement from X to Y, so from 4 units to 3 units, this gives a trade-off or a gain of 3 more units on X. So this is what we call the marginal rate of substitution. So there are several formulas that we need to factor out in this particular topic. So we have price of good X times X plus price of good Y times Y. So we have the marginal rate of substitution, X for Y, where we start with the formula price of X over the price of Y. This marginal rate of substitution is also the same as the formula of the slope, the price of X over price of Y. Then if you're asked to find the marginal rate of substitution Y for X, it's the opposite, negative P Y over price of X. So you're substituting a certain number of goods of X for Y. Then we also have the optimum bundle, which occurs at the point when the marginal utility of X over the price of X should be equal to the marginal utility of Y over the price of Y. This sometimes we use what we call the Lagrangian multiplier. This Lagrangian multiplier, given a utility function X comma Y, is such that M minus price of X, X minus price of Y, Y. So this is the same as that. So I'll show you how to quicken this procedure. Okay. So we're going to look at a basic example before I look at the computations of utility. So we will be asked to calculate the functions given those. So in this question here, we are told that okay, where's the question? Okay, here, part C. Part C. So suppose a consumer's income is 1,000, the price of good X is 100, and the price of Y is 200. So let's analyze this before we even tackle the questions. We're told that the income is 1,000, the price of good X is 100, the price of good Y is 200. Okay. How do we come up with the budget line? Anyone? So to come up with the budget line, you remember the formula for the budget line? Income is equal to what? Price of X times X plus price of Y times Y. So we're going to say 1,000 is equal to what? 100 X
200y.
200y. Okay. Are we together? Then are we all together?
Yes.
Then this function will also help us plot. Now I was teaching you how to plot linear equations. That to plot at x and to plot at y is simply dividing the coefficient. 100 into 1000, we get 10. 200 into 1000, we get what? 5.
5.
So this means that we're going to sketch this, the y and the x here. It will cut the y at 5 and the x at 10. So what does this mean? This is 0, 5 and this is 10, 0. So if all the money was spent on good x, it means good x would consume only 10 units and 0 units of y. If all the amount was consumed on good y, we could consume only 5 units of y and 0 units of x. So this is what it means. So if you're asked to calculate the slope is simply, who remembers? Price of good x over price of y. So this would be negative what? 100 over 200, which is got what? Negative 0.5. Okay. Is that clear?
Yes.
So now, who wants to help me find the marginal rate of substitution x for y? Marginal rate of substitution x for y. So marginal rate of substitution x for y is the same as the slope. We are simply dividing the price of x, which is negative 100, over 200, which is negative 0.5. So this means that for every 1 unit of x, you substitute for 0.5 units of y. If they ask you to find the marginal rate of substitution y for x, it is the price negative for y over price for x. So this is what? Negative 200 over 100, which is negative 2. So it means for every 1 unit of y, you substitute with 2 units of x. That's what it means. Now, before I explain any further, I have over answered the question. Let's look at what the question was asking for. Suppose the income is what? 1000. The commodity x is 100, commodity y is 200. What is the equation of the budget line? So this is 1000 is equal to what? 100x plus what? 200y. Indicate the number of x the consumer would purchase if she spent all the income on commodity x. So just divide this family value of x into 1000. So 1000 divided by 100. We get how many units? 10 units. About how many units of y if we spend all of it on y? 1000 over 200. So this is 5 units, 2 marks. Write the slope is equal to what? Price of good X, which is 100, over price of good Y, which is 200, which is negative what? 0.5. So how many marks for this? 8 marks, which you cannot afford to lose. Is this clear?
Yes.
Now, suppose the question was what? Manipulated. If the income increased from 1,000 to 200 to 2,000, but still maintaining the same price of good X as 100 and good Y as 200. So income will cause a shift outwards. So originally we are at what? 10, 5 for Y and 10 for X. So income has just doubled here. This simply means that our curve will shift outwards, meaning you're able to buy double of each unit. Instead of buying 5 units of Y, we're going to buy 10 now, because 100 into 2,000 is 20, and 200 into 2,000 is 10. But if the same happened, and instead of having 1,000 here, we went to half of it, 500. This will simply means that the curve will shrink inwards. We're going to buy half of whatever we had here. So instead of 5 here, we have 2.5. Instead of 10 there, we're going to have 5. So this is a shift that happens as income increases or income decreases. So it's called a what? A shift. But if one variable changes whilst maintaining the same 1,000, but instead of writing 100 there, maybe it doubles from 100, it's now 200. Okay, the Y remains the same, but our X, instead of 100, it becomes maybe 200, it's doubling. So what this means is there will be a tilt on the value that we are doubling. So what is happening to good X? It's becoming expensive. So inevitably we're going to what? Demand less of it. So initially we had what? 10 units of good X, but now we're going to have 5 units. So a tilt inwards, because the good X has become expensive, we're going to buy less of it. Suppose instead of 100, doubling, what will happen if it became smaller, maybe from 100 to 50 quart, 50x. So the opposite will happen, will tilt outwards. So meaning we'll be able to afford more of good X from 10 units maybe to 20 units. So this is called a tilt. Is that clear? So even without calculations, suppose good Y, whilst maintaining good X at 100, suppose good Y doubled to 400. What do you think would happen on this curve? What will happen to good Y with reference to the original? The original was what? 5 and 10. Could somebody tell me what would happen? From 200, it has doubled to 400. I'll give you a clue. It will tilt, but where and how? Okay, the tilt will be on Y. Will it be inwards or outwards? The tilt will be inwards
Inward.
to 2.5, meaning we're going to afford less of what? Of good Y, because it's become expensive. If Y, on the other hand, instead of 200, it became 100, will tilt outwards from 5 maybe to 10. The tilt outwards is because it has become cheaper and we're going to buy more of that. So this is basically on consumer behavior and how the curves move. So this is the simplest you could ever get to understand. That is part 1. Part 2 is now understanding how the indifference curves move. Remember, one of the properties I said is that indifference curves illustrate an optimum point where the budget line kisses the indifference curve. So this utility function, at this point, we'll calculate the maximum units of good y and good x that will maximize utility. So we know that this is called the optimum bundle. Marginal utility of x over price of x should be equal to marginal utility of y over price of y. So let's go back to our calculus. Remember, if we have 2x, 5, y3, we have y, 10x, y2, we have u, 2x squared, y4. Let's differentiate each of these ones. We have u, 2x half, y half, and finally, we have u, xy. Please don't embarrass me. How do you differentiate these? For the first one,
You multiply 2 times 5,
yes,
which will come 10x to the power 4, and then 3y to the power 2.
so
Right, sorry.
10x4, y3. So we're only differentiating this.
All
Then
right, okay.
the dummy. How about marginal utility? The same question, marginal utility of y. We're differentiating. So our x, 5 remain as it is. So we're differentiating the other two. So we're going to have what? 6 y2. Okay. 1, 2, 3, 4, 5. So this is question number 1. Question number 2, marginal utility of x. Which one is our dummy? y2. And what are we differentiating? 10x. So 10x is 10. Okay. How about marginal utility of y? What are we differentiating? Our dummy in this case is what? X. We're going to remain with what? 10y2, which is 20. 20y1. Okay. I'm glad you're following, especially those who were in my class yesterday. Then here, our marginal utility of x. Which one is our dummy? y4.
Y.
And what are we differentiating? 2x2, which is what? 4x.
X.
Okay. How about marginal utility of y? What are we differentiating? Which one is our dummy?
X.
x2. What are we remaining with? 2y4, which is what? ay3. Number 4, when we differentiate that, what is our dummy? Y half. Then we differentiate y half, it becomes what? X minus half. Because half times 2 is 1. Whenever I write 1, half minus 1 is negative. So the negative is on the x. How about the marginal utility of y? Which one is our dummy? Our dummy this time is, we're interested in the y. Our dummy is what? X half. So we're differentiating now. We're going to remain with 2y half, which is what? Y negative half. All right. Then finally, number 5. Marginal utility of x. Which one is our dummy?
Y.
We're going to remain with 1x. 1x differentiated, just 1.
That's
Then
1.
utility of y. Our dummy in this case is what? X. When differentiate 1y, it's just 1, which will not appear. So this one ends as follows. So with that being the recap, let's do serious business here. I'll use one of the functions that we have already differentiated there. Suppose we have 2x half, y half, and the income was given by 80, and the price of x was given by 10. The price of Y was given by 40. So number one, write down the optimization problem or the budget line. Who wants to help on the budget line? This is easy. Budget line is given by what? M is
MU
PXX.
plus PY. Y.
So here we're going to have what? 8
NX.
10x plus what?
40Y. 40Y.
So even sketching it, who wants to help? On the Y, where we did cut. On the X, where we did cut. Okay, help me with that. So to cut the Y at what?
To cut the Y at 2.
And the X at?
8.
Y at 2. X at 8. Correct. So now we want to calculate the point at which we maximize our utility functions. Who remembers our maximization bundle? MUX over the price of X as equal to MUY over the price of Y. So when you differentiate this, remember our MUX was what? The negative was on the X. When you differentiate it, our negative was on the what? On the Y.
Yeah.
The price of good X was what? 10. The price of good Y was what? 40. According to indices, the letter with the negative will go down. Which letter goes down in this case? X. Then here, which letter goes down? The Y is one which goes down, right? The Y will join the 40 there. So the one with the negative is one that goes down. So you cross multiply here. 10x half times x half, it is 10x. Because a half plus half gives you 1. Y half times 40y half gives you 40y. So when you divide by 10, both sides of x is equal to 4y. Now, after finding that, you substitute it back into the original function optimization problem. So where there is x, we're going to put what? 4y. So in this case, we're going to have 80 is equal to 40y plus 40y. So 80 here is equal to what? 80y. So meaning our y is equal to 1. So how do you find the x? And substitute it in here. Our x is equal to 4 times 1, which will give us a 4. So this is where we get the values now here that maximize. So of y, it is 1. Of x, it is 4. So this carries 10 marks, the optimum bundle. This does not miss. So if we follow through, so the question I now need you to try is the one in your handout. I'll just start to guide you. This one came in one of the exams. Given the utility function, 10x half, price of x is 10, price of y is 5. The income is 150. What is the optimal bundle? So who wants to try firstly what we can do together within a minute? What is the budget line?
M, okay, is equal to
Mhm.
Px
Mhm.
plus Py.
Mhm. So what is that the function now?
So
1
it will be
is equal to
10x.
the income is 150, then 10x plus
10x plus 5y.
okay. Then you can sketch this. On the y, it will cut 10 into 150, 15. 15 into 150 is 30 on the y. So I've started for you. I want you to finish this. Just capture this and I'll give you 5 minutes to try. You can capture this. I'll give you 5 minutes to try, then we start another session. Please give me the solutions for the optimum bundle.